Hi all, welcome to our new session. So I hope you have gone through all the topics which we have discussed in our previous session. So before starting our new session, I am just revising the term. So the most importantly, the physical significance of moment of inertia. So the physical significance of moment of inertia, you know, the linear acceleration is caused by external force in translatory motion, and the mass will oppose that external force which tends to change the state of rest or of uniform motion. Similarly, in the case of rotational motion, torque will produce angular acceleration and the moment of inertia will oppose that torque. So moment of inertia will play the same role of mass in translatory motion. So this is the most important question you need to expect. It is the physical significance of moment of inertia. So next in this session, we are just discussing the theorems of moment of inertia. We need to discuss two theorems, so which is very useful if you want to find out the moment of inertia of different bodies of various shapes. And the first theorem is called parallel axis theorem. So this is the parallel axis theorem. Here the summary of the theorem is, suppose you have a rigid body, you can see this rectangular rod is the rigid body, and you need to find out the moment of inertia of this body about an axis which is passing through one of its edges or one of its ends, and you know the moment of inertia of the same body about an axis which passes through the center of mass. Then the parallel axis theorem states that the moment of inertia of a body about any axis is equal to the sum of the moment of inertia of the body about a parallel axis through its center of mass and the product of mass of the body and the square of the distance between the axes. Mathematically we can write, if I is the moment of inertia, we need to find out, if I is the moment of inertia, we need to find out I equal to, so this is the moment of inertia of the same body about an axis, about a different axis, and we know the moment of inertia of the same body about an axis which pass through the center of mass. So the statement is, it is equal to the sum of the moment of inertia of the body about a parallel axis through its center of mass. Let ICM be the moment of inertia of the body about an axis passing through the center of mass, and we know what is its value. So I equal to ICM plus what? Product of mass of the body. So it's plus product of mass of the body and the square of the distance between two axes. Let R be the distance between these two axes, then I equal to ICM plus MR square. I equal to ICM plus MR square, and this is the parallel axis theorem. So parallel axis theorem states that the moment of inertia of a body about any axis is equal to the sum of the moment of inertia of a body about a parallel axis. So these two axes must be parallel to one another, is equal to the moment of inertia of the body about a parallel axis through its center of mass and the product of total mass of the body, and the square of the distance between two axes. So I equal to ICM plus MA square, where ICM is the moment of inertia of the body about the center of mass, M is the total mass, and R is the distance between these two parallel axes. Now we need to prove this parallel axis theorem. So for this we are considering a rigid body. So I am just considering a rigid body of mass capital M, okay, of mass capital M, and we require to find out the moment of inertia of the same body about an axis PQ. So this is PQ, about which we need to find out the moment of inertia of the body, and there is another axis RS, there is another axis RS which pass through the center of mass, and we know the moment of inertia of the same body about the axis which pass through the center of mass. So finding the moment of inertia of this body about the axis PQ, we are just considering a small particle here of mass small m, of mass small m. Let this particle is at a distance of x from the axis which pass through the center of mass, and the distance between this PQ and RS be A. Okay. So, in brief, we are just considering a body of mass capital M. We need to find the moment of inertia of the same body about PQ, and there is another axis RS which is at a distance of A from PQ and passes through the center of mass. We are considering a particle of mass M which is at a distance of x from RS. So, the distance of the particle of mass M from PQ is what? It is x plus A, right. So, the particle is at a distance of x plus A from PQ. So, can you say what is the moment of inertia of this mass about PQ? Moment of inertia of mass M about PQ, just use the formula. Moment of inertia is nothing but the product of mass and square of the distance from the axis. So, it is equal to what? M into x plus A, which is the distance, the square. It is M into x plus A, the whole square. Imagine the body is made up of a large number of similar particles of mass M. So, moment of inertia of the whole body I is given by sigma M into x plus A, the whole square. So, just use the identity and take the summation on each term. So, it is given by sigma M x square plus, it is x square plus 2ax plus a square. So, it is another term is sigma M a square. So, next it is 2ax into M. So, it is sigma into 2 mxa. So, these are the three terms, sigma mx square plus sigma ma square plus sigma 2 mxa. And we know moment of inertia of the rigid body about the axis which passes through the center of mass is given by what? I equal to, or ICM equal to sigma m x square. So, this is nothing but it is a moment of inertia of the body about the center of mass. So, it is given by ICM, which is the moment of inertia of the rigid body about the center of mass, plus sigma m a square. What is A? A is the distance between these two axes, it is not varying, it is a constant. So, it is nothing but you can rewrite this term as A square into sigma m. What is sigma m? It is the total mass of the body. So, it is given by the second term as m into a square, ICM plus m into a square. And the third term here 2 and a is constant. So, 2a into sigma mx, 2a into sigma mx. So, there is an additional term, there is an additional third term. We need to know what is the value of that third term. And this sigma mx, which is called the moment of mass about the center of mass. To clarify the thing, I am just considering a situation. Suppose you have a rod having this shape. So, the mass is concentrated more at one side, or you can consider a rod heavy mass at one end and a smaller mass at other end. Can you say where will be the position of the center of mass? It will be shifted towards this side, right. So, this is capital M and this is small m, and the position of center of mass will be somewhere here C, which is at a distance of x1 from capital M and x2 from small m. The moment of mass is nothing but mass into distance from the center of mass. Here we can what? We can handle, or we can hold the particle, whole system at the point, at this center of mass, because here m into capital M into x1 must be equal to what? Small m into x2. The product must be same, equivalent, opposite, so that they cancel each other. That's why we are able to hold the system at the center of mass. In short, the moment of mass about the center of mass will cancel out. Similar will be the case here also. Here sigma mx, it is the sum of the moment of mass around the center of mass. So, it will cancel out, it is 0. So, we will get it is equal to ICM plus MA square. So, hence the theorem. We have stated that parallel axis theorem is nothing but it is the moment of inertia of the rigid body I equal to moment of inertia of the body about an axis passing through the center of mass and the product of total mass of the body and square of the distance between the axes. So, this is the proof. So, this is very important, you need to expect a statement and proof from this session, state and prove parallel axis theorem. So, similarly another important theorem is there, which is the perpendicular axis theorem. So, we need to learn two theorems, parallel axis theorem and perpendicular axis theorem. Here perpendicular axis theorem states that the moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to the sum of the moment of inertia of the lamina about two axes at right angles to each other within the same plane and intersecting each other at the point where the perpendicular axis passing through it. Suppose this is the lamina, you can see this blue one, this is the lamina. Here you have an axis IZ. So, the statement is moment of inertia of a plane lamina about an axis perpendicular to its plane. So, this is that axis which is perpendicular to its plane IZ. It is equal to the sum of the moments of inertia of the lamina about two axes at right angles to each other. Here we can have another two axes x and y, and these two axes are at right angles to each other. Here Ix is the moment of inertia of the lamina about this axis, Iy is the moment of inertia of the lamina about this one, and these two axes are right angles to each other, and the next point is it must pass through or it must intersect each other at the point where the perpendicular axis passing through it. So, these two axes intersect at a point where the perpendicular axis passing through it. Then the theorem states that the moment of inertia of the lamina about the axis, about the perpendicular axis Iz must be equal to the sum of the moment of inertia of the lamina about other two axes. This is what perpendicular axis theorem. So, this is a statement of the perpendicular axis theorem. So, if you have a lamina and if you are going to find out the moment of inertia of a lamina about a perpendicular axis, if you know the moment of inertia of other two axes which are perpendicular to each other, importantly within the plane, and intersect at the point where the perpendicular axis passing through it, you can simply write Iz equal to Ix plus Iy. Now, we need to prove the perpendicular axis theorem. For that we need to consider a plane lamina. So, I am just considering a rigid body or lamina. I am just considering a lamina and I have two axes Ox and Oy, and they are at right angles to each other, and we need to find out the moment of inertia about the third axis which is perpendicular to this plane and passing through the point of intersection of other two axes. So, that axis will be in this manner, right. So, I am just considering a particle here. So, I am just considering a particle P which is at a distance of r from O. I am just considering a particle P which is at a distance of r from O. So, this is, and the particle is at a distance of y from Ox, and it is at a distance of x from Oy. So, this is the position of the particle, it is at a distance of r from O, y from Ox, and x from what? P. So, the moment of inertia of the particle about Ox. So, it is moment of inertia of the particle I about Ox is given by, So, the particle is having mass small m. What is the answer? It is m into square of the distance. What is the distance? It is y square. So, m into y square. So, this is the moment of inertia of the particle about OX. And imagine the lamina is made up of a large number of such particles. So, the moment of inertia of the whole lamina, so this is I dash, and the moment of inertia of the whole lamina, let it be I, about OX is given by sigma m y square. Similarly, the moment of inertia of the lamina about OY, let it be I OY, is given by sigma m x square. It is given by sigma m x square. So, what is the moment of inertia of the whole lamina about OZ? So, this is the axis about OZ. So, the particle is at a distance of r from this perpendicular axis, right. So, it is at a distance of r from perpendicular axis. So, the moment of inertia of the lamina about OZ equal to sigma m into r square, because it is at a distance of r from that perpendicular axis. So, what is r? You can use the Pythagoras theorem, r equal to r square equal to x square plus y square. So, sigma m into x square plus y square, it is equal to sigma m into x square plus y square. So, it is sigma m x square plus sigma m y square. What is sigma m x square? Sigma m x square equal to I O Y. What is sigma m y square? It is I O x. So, we arrived at the final expression, the moment of inertia about the perpendicular axis OZ, it is I OZ equal to the sum of moment of inertia about other two axes, which is I OX plus I OY. Hence, we proved perpendicular axis theorem. So, these two theorems are very important, parallel axis theorem and perpendicular axis theorem. So, you need to learn these two theorems because we need to expect the questions from both parallel axis theorem and perpendicular axis theorem. So, at this point I wish to conclude this session. So, you please go through these two theorems and please understand what is the main important concepts. So, thank you, bye, see you on next session.